inverse meter inverse. As you know, the relation between conductivity and resistivity is rho is equal to 1 upon sigma. Once you know sigma, you can easily calculate rho, that is 1 upon 2.32. So by calculating this answer, you will be getting 0.431 ohm meter. We all know that R depends on length and area. So the equation of resistance becomes R is equal to rho L by A. We are having resistivity rho, length L and area A. So let us calculate. Rho is 0.431. The length of specimen is 1 millimeter. That is 1 into 10 raised to minus 2, and the area is 1 into 10 raised to minus 3. So by calculating these values, we will get the resistance, that is 4310 ohm. So in this way, you can calculate the resistance of any given material. Now let us recall what we have seen. Friends, we started with properties of materials. So if we recall it, that there are 8 properties. The first property is the conductivity, thermal conductivity and electrical conductivity is very high. Second property is about the Ohm's law, that is R is equal to V by I. Here it is, you can say that under steady state only the Ohm's law is obeyed. That means generally we plot the graph as V by I, V versus I, like this. Linear relation can be seen, but after certain points there will be curved nature. That means it is not obeyed in all the cases. The third property is about debase temperature. As you know that the debase temperature is the temperature at and above which the atoms and molecules behaves classically rather than quantum mechanically. That means vibration energy is much more important. Here, above debase temperature, the resistivity will be directly proportional to the absolute temperature T. At low temperature, the resistivity is directly proportional to 5th power of absolute temperature T. What about pressure? The pressure is inversely proportional to resistivity. The sixth property was Wildemann-Franz law, that is, the ratio of thermal conductivity K and electrical conductivity sigma is directly proportional to absolute temperature T. That means K by sigma is equal to LT, where L is Lorentz number. Next property was about superconductivity, that was given by Ohms. So, at absolute zero temperature, the resistivity of any material tends to 0. That means it behaves like a superconductor. The last property is magnetoresistance effect, and it is the relation between magnetic field and conductivity. So we can say that the conductivity of metal varies in the presence of magnetic field. These were the properties of these materials or metals. Now we can distinguish between metals and bad conductors. Then we have seen 3 different types of models. In first model, that was free electron theory, that was given by Drude and Lorentz. So it is also well known as Drude-Lorentz theory. The second theory is quantum free electron theory, which was given by Sommerfeld. So it is also known as Sommerfeld theory. The third theory was band theory or zone theory. After this, we have seen the assumptions of free electron theory. Then we have solved few numericals, and you have also seen one very good experiment shown by our students of GSET Engineering College. We have solved few numericals. In last, we have seen some drawbacks, failures and successes of free electrons theory. So we can say that, we can conclude like that, this Sommerfeld theory can prove certain things like wave nature of atom, while in the first one, free electron theory, which cannot be shown. So we cannot show the phenomena like Compton effect or photoelectric effect using free electron theory. Just going back to the slides, I give you one assignment. You just tell me whether the statement is right or wrong. All the material which are good conductor of electricity are also good conductor of heat. Friends, this assignment is supposed to be finished by today only. With that, let us depart. Thank you. Thank you very much.